Welcome to The Explainer. Today, we're going to pull back the curtain on the web. We're going to uncover the foundational technologies that took the internet from, well, a collection of static digital pages and turned it into the vibrant, interactive world we all live, work, and play in every single day.
I mean, it's a great question, right? That jump from those old, kind of clunky, rigid websites to the fluid, fast applications we use now, it wasn't magic. The answer really comes down to this massive shift that happened back in the late 90s. It was a moment that introduced a new set of tools that, for the first time, allowed the web to really come alive.
Okay, let's get into it. So think about it. In the early days, the web was basically just a digital library. You could look up information, you could read it, but you couldn't do anything with it. As you can see on this timeline, the real turning point was 1997. When Microsoft released Internet Explorer 4, they introduced this concept called DHTML, and that right there changed absolutely everything.
So, what in the world is DHTML? Now, this is a really crucial point. DHTML isn't one specific programming language that you can just go and learn. Think of it less as a language and more as a recipe, or maybe a better word is a team. It's a collection of separate technologies that, when you use them together, lets you create the interactive and even animated websites that we just take for granted today.
And this right here breaks down that DHTML team for us. So first up, you've got HTML. That's the skeleton, the absolute backbone of any web page. It gives you the raw structure and the content. Then you have CSS, which handles all the presentation, the colors, the fonts, the layout, how everything looks. And then you have the secret sauce, JavaScript. That's the part that brings it all to life with logic and interactivity. Let's use an analogy here because it makes it super clear how they all work together. Think about building a house. HTML is the blueprint and the construction crew. It builds the foundation, the walls, the floors. You get the basic structure. But you know, it's just a boring gray box. That's where CSS comes in. It's the interior designer. It adds the paint, picks the furniture, hangs the decor. Now it looks good, but it's still just a static model. JavaScript? That's the electricity and plumbing. So it lets you flip a switch to turn on the lights or turn a handle to get water. It makes the house actually functional.
And the result of this teamwork was an absolute game changer. For the very first time, a script could do things right there inside your browser. Think about a simple calculator on a web page. Before DHTML, you'd type in your numbers, hit submit, and the entire page would have to reload from the server just to show you the answer. It was slow, it was clunky. With DHTML, JavaScript does that calculation instantly on your machine with zero reloading. That made the web faster, way more user-friendly, and for the first time, truly interactive.
Okay, so this brings us from the what to the where. All this cool stuff, all this DHTML magic, the animations, the instant calculations, it's all happening on what we call the client side. And that's really just a fancy way of saying it's happening right there on your computer, inside your web browser. But of course, your computer isn't an island. It's connected to a much, much larger system.
And this is that system. This is the fundamental client-server model, the absolute bedrock of how the web actually works. You see how the work is split in two? The client side, that's your computer. It runs the code for everything you see and interact with. That's DHTML's playground. But the server side, that's a powerful remote computer that does all the heavy lifting. It manages the gigantic databases, the core application logic, and all the security using powerful platforms like J2EE. This division of labor is the basic blueprint for the entire internet.
Now this simple two-part structure, one client, one server, has a name. We call it a two-tier architecture. It is the most basic, foundational pattern for how information moves online. And for years, this was totally fine. A simple blog, a small online shop, a basic company website, they all fit perfectly into this nice, clean model. But what happens when that website gets really, really big with millions of users and super complex features? Well, that simple structure starts to buckle under the pressure. And that is the exact problem that modern applications ran into. For these huge, large-scale systems, think online banking or massive e-commerce sites, a simple two-tier system just can't cut it. The server gets totally slammed trying to handle user interactions, all the business logic, and queries to a massive database all at the same time. The whole thing would just grind to a halt. So what's the solution? You add more specialized layers. And that brings us to a classic 3-tier architecture. Let's just walk through this example. Okay, so Tier 1 is you on your client computer, and you search for science. Your request goes to the web server, which is Tier 2. Now, this server is like a receptionist. Its job is to handle web traffic, but it doesn't store all the company's information itself. So it turns around and asks a totally separate, specialized database server in Tier 3, "Hey, I've got a request for science. What can you find for me?" The database server does its job, finds the data, sends it back to the web server, which then assembles the final page and sends it all back to you. See? Each tiering has one specific job, which makes the whole system way more efficient and way easier to scale up.
This whole idea of adding specialized layers whenever you need them is called N-tier architecture. And that N just means it could be any number. 3 tiers, 4 tiers, 5 tiers, whatever the application needs to run properly. By separating all the functions into different tiers, one for what you see, one for the business rules, one for the data, you can manage, update, and secure each part on its own without accidentally breaking the whole system.
So what's powering all of this incredible server-side complexity? Well, you need really robust, heavy-duty platforms. And that's where something like J2EE comes in. That stands for Java 2 Enterprise Edition. And this isn't your basic Java. You can think of it as Java on steroids. It's a whole environment built specifically with all the services and protocols needed to build, deploy, and securely run these absolutely massive, multi-tiered applications that are the true backbone of the modern internet.
So, let's do a quick recap of this whole journey. We started with DHTML. That's the team of HTML, CSS, and JavaScript that first made web pages interactive right on your machine. Then we saw how those clients talk to servers using the fundamental client-server model. And finally, we explored how that simple model has to evolve into N-tier architecture, which is what allows today's incredibly complex applications to scale and not fall over.
And all of this leaves us with a pretty fascinating thought. We've gone from static pages to 2-tier to 3-tier to N-tier systems. But, this evolution is far from over. As we start integrating things like AI, machine learning, and huge streams of real-time data, you really have to wonder, what's the next tier of the internet going to look like? What new layer is going to emerge? Because whatever it is, you can be sure it's being built on the very foundation that we've just explored right now.